Today I'm gonna talk about the derivative of composite function, chain rule, specifically trig function and general power rule, part 1. And firstly, we're gonna recall what is general power rule. The general power rule can be written as the derivative of fx to the power n equals n times fx to the power n minus 1 times derivative of fx. Okay. I also list the standard power rule, that is derivative of x to the power n, that equals n times x to the power n minus 1. Okay, let's compare these two power rule. We can see the general power rule gives us the extra term, that is derivative of fx. Okay, that's the extra term. Now, I also list some other formulas. The third one is the derivative of constant times a function fx equals the constant times the derivative of this function. We called this guy as constant multiple rule. And the fourth one is derivative of sine x equals cosine x, derivative of cosine x equals negative sine x, derivative of tangent x equals secant x squared. Now let's take a look at the first example. So let's take a look at this guy. We can easily identify fx. The fx is sine x, right? That means it's fx squared, or fx equal fx squared prime. Okay, so now we can follow this formula, which is follow this formula. Here n is 2, and fx to the power n minus 1 should be sine x (2 minus 1), and the derivative of fx gonna be a derivative of sine x. Okay, now we have 2 sine x, and the derivative of sine x gonna be a cosine x. Now we finish the first example. Now let's take a look at the second example. The second example, we can see what is fx. Fx is 2 cosine x plus x. Okay, and the n is still 2, right? Now we're gonna plug in the formula, right? So we have 2 fx to the power n minus 1 should be 2 cosine x plus x 2 minus 1 times the derivative of fx. So we'll have 2 cosine x plus x prime, and we have 2 cosine x plus x. 2 minus 1 is 1, and here we have derivative of the sum of two functions. That means we're gonna do the derivative of each function. Okay, now we're gonna evaluate these two functions. That is 2 times cosine x plus x, and we have here 2 times cosine x. That is formula 3 here. So we're gonna keep the constant 2 here, and do the derivative only for the cosine x. And the derivative of x gonna be 1. Follow the power rule, right? So derivative of x gonna be because the exponent is 1, we should be 1 minus 1. X to the power 0 gonna be 1. So here should be 1. Now we can simplify it and find the answer. Here, the derivative of cosine x equals negative sine x. Gonna be negative 2 sine x plus 1. Okay. Now let's take a look at the last example. For the last example, we can tell what is fx. Fx is phi tangent x plus 2x squared. Okay, now let's follow this general power rule. And here n equals 3. So we have phi tangent x plus 2x squared. We have 3 minus 1. Okay, and do the derivative for the fx. That is phi tangent x plus 2x squared prime. Okay, we have here 3 minus 1 equals 2. So we have phi tangent x plus 2x squared. And again, here the derivative of sum of two functions gonna be the derivative of each function. Okay. And we can tell here is a constant times a function. We're gonna use constant multiple rule. Okay. So we have phi, we're gonna keep the constant. Phi is the same. Okay. We copy this one firstly and do the derivative for the tangent x. And of course, we're gonna do the derivative for the x squared. Now we can simplify it. We're gonna have 3 phi tangent x plus 2x squared, and the tangent x, we know derivative of tangent x equals secant x squared. So we have phi times secant x squared, and here we can know x squared prime. That means we can apply the standard power rule. Okay, standard power rule. That should be 2x to the power 2 minus 1, and the last one, or last step, 3 times phi tangent x plus 2x squared to the power 2 or square. We have phi secant x squared plus 4x.